Future Hacker, Life, Path, Future.
Hello everybody and welcome to the international edition of Future Hacker. This is our host, Maria Taide. Today we're talking to Carlos Torres. He's an expert in mechatronics and information technology applied to predictive maintenance in industrial machinery. He's the CEO of Power MI, where MI stands for Maintenance Intelligence, and offers cloud condition monitoring solutions. Hi, Carlos. How are you? Great to have you today with us.
Hi, Maria. Thank you for having me.
So before we begin our interview, would you like to just give our listeners a quick overview of your background?
Yes, sure. My background, I'm mechanical engineer, graduated in my home country, El Salvador. Then I was working for 3 years as a predictive maintenance engineer in El Salvador, in a cold rolled milling, in a factory. Then I went to study a master in science of mechatronics in Germany. Afterwards, I was working for a German company called Prüftechnik, where we produce and commercialize predictive technologies for industrial machinery. I spent about 11 years at Prüftechnik. I worked in Germany, in Spain, in Portugal. Then I was doing business in Latin America, in the US as well. Then I made a Harvard Business School program, the General Management program, where my mind blows and I think about the concept of these new industrial technologies or these digital or exponential technologies to be applied to the industry. So basically, my background is a mechatronics perspective of the industry with a clear vision with these exponential technologies.
That's pretty awesome, Carlos. I just love this whole international experience that you have. So let's jump to it. You know, the rise of the digital industrial technology is a transformation that makes it possible to gather and analyze data across machines, enabling faster, more flexible, and more efficient processes to produce higher quality goods at reduced costs. So this is not really a new topic when we talk about Industry 4.0, as it started so many years ago with the use of robotics in the manufacturing industry. But, you know, as we're usual here in Future Hacker, the speed of innovation is exponential. So currently we are talking about this evolving industry with the use of artificial intelligence capabilities, machine learning, communication with other robots, and even communication between robots and humans. Not to mention the use of big data, the supply chain integration, and so on. So could you please give us an overview of the current possibilities and where is the future headed?
Well, currently, what we are seeing now is that we can predict the demand of many products. I think one of the best examples is how the Weather Channel, together with Pantene, could predict the shampoo's need based on the weather data. It means for some local regions, we could know a couple of days in advance if the demand of shampoo will rise or will decrease based on the weather data. So that's a clear sign that the big data can help production and distribution and planning. In production lines, we see an industrial plants forced to increase their reliability. So that's why predictive maintenance is now booming. Before we were only some few guys talking about this. Nobody wanted to listen to us, and now it's something they are looking for us. That's a cool stuff for us, actually. So predictive maintenance, which is also called condition-based maintenance, it means that you will work on an asset only when it's required. So what we are seeing now is a booming of the sensors on machines. So it means as the sensor and the hardware get cheaper and cheaper, we can, let's say, sensorize more and more assets or machines, and we can get their operation conditions very accurately and almost in real time. So if we can manage this old data, we can predict the machine failures and then act before it happens. So, but right now the bottleneck is the communications. I mean, this IoT, this communication between machine, and the availability to find that data scientists, which are currently IT guys or guys able to create and analyze algorithms and data. So this availability of qualified people is the real bottleneck. But once the bottleneck is overpassed, we are heading to an entire predictable supply chain. So from the demand to the production, and then to the distributions on any product. So ideally, what we can expect is that we can deliver a product to a customer's door even the day before he wants it. This is actually what the social networks are doing now. And that's, I think, the integration of all this chain of production, distribution, and discovering what the customer will need is the near future, I would say.
That's pretty great. I didn't know regarding Pantene, so that was a great example. It makes a lot of sense to me, as you know, probably the type of shampoos are changing depending on the weather and the volume and everything. And you know, when you talk about just working on the machines when it's actually needed, it just sounds to me that it's really something cost efficient, right? So let's go back. You told me that you went to Germany, right? You studied there. And when I was reading about Industry 4.0, you just see a lot of Germany coming in, right? It's like the leading example. And actually, if I'm not wrong, it was the country that actually began this movement. But when it comes from developing countries, the adoption of those new technologies, they seem so out of reach for many companies, especially because those solutions usually come from abroad. In countries like Brazil, you need to deal with the currency exchange, the high taxation, the lack of support sometimes. So as much as it could be an opportunity for local development, then we get into this whole discussion regarding the challenges of local infrastructure, the quality of education. So how do you see the spread of the adoption of disruptive technologies in that context? How could developing countries just drive the path? Do you think it will occur when it just stops being a competitive advantage as it is today and it actually turns into an obligatory need, like the regular cost of doing business? And what do you think regarding government involvement to subsidize technologies that make positive impact in the environment, for example, like saving energy or decreasing the risks of environmental hazards?
You're right. Industry 4.0 was initially a German government project to help German factories to what we call at this time the digital transformation or the smart factories. In 2010, I remember that during the Hanover Messe or Hanover Fair, the German government made a call for academic and industrial leaders to create kind of committees, local committees, and then regional committees, and then national committees to discuss and give the guidelines to small and big factories to start this digital transformation. Actually, I know people who was integrated into these committees, and I asked them, okay, what 4.0 means? And they call it that way because they consider we are now in the fourth industrial revolution. And then I asked why the .0, and they say, I don't know, because at this time they told me they didn't know the huge impact of this term. It was just the name of a project, and it's a public term, so anybody can use. This is what we listen or what we hear Industry 4.0 for many marketing purposes. But this is based that we are on the fourth industrial revolution. So just to be brief, the first industrial revolution was the disruption of the steam machine, creating the first factories. The second was the electrical motor, making the assembling lines and the mass production. The third industrial revolution was the programmable logic controllers, or PLCs, making the production lines automatization. And the fourth industrial revolution has more a non-tangible element for disrupting. And the closest explanation is from the Fraunhofer Institute, which is a huge organization in Germany for research and technology transferring. But they say that the fourth industrial revolution disrupting element is the cyber-physical space. So these new technologies, these new digital technologies can be used to exchange data and provide useful information to the industry to make the right decision. This is in short. But I do business with big corporations, and I see the change because before they probably used to tell me that their main advantage is that they have many factories or plants, and they can compare some indicators, and in that way they can predict some problem because they have this kind of knowledge. Basically, it was a benchmark, if you want to keep it simple. But now, what we see now that any company, and I can tell you a lot of examples of this, any company can use the same technology, using the same knowledge, and can have pretty much the same knowledge or the same information to make the right decision. And it doesn't matter of the size of the company. It's just a matter to use the right tools. And this is why it is a revolution. Because that technologies or that knowledge that was only available for big corporations, anybody can use them. So when I teach digital transformation in Latin America, many students tell me, hey, come on, Carlos, this is Latin America, so we are far from that. And always my answer is that if we think on that way, we are losing maybe a big opportunity to take advantage of these new technologies, because this is a kind of shortcut to get the operational excellence at a minimum cost. So this is somehow a kind of industrial hacking to get our companies to some level that before was impossible. And that's, this is like democratizing the knowledge and the technologies and the ability to many companies to do the right things before was never possible. So the government roles is to, I'm not a big fan of subsidizing technologies, but I think the government's role is to facilitate the access to new technologies and encourage companies to use these technologies to reach their operational excellence, to increase their competitiveness, basically.
I just love this phrase, like, come on, Carlos, this is Latin America. That's something we hear a lot, right, when it comes to new technologies. And it's great to hear that that's something that is not as far and is not as out of reach as we might think. But, you did mention before that you have this bottleneck of qualification of the workforce. So let's get into that, because if you have it there, for sure you have it here as well, right? So this movement, we've been seeing this change on the skill sets needed from the employees. So we see that the manual and simple and repetitive work, they're gradually being replaced by machines. At the same time, we have the growing usage of software, connectivity, analytics, and that increases the demand for employees with competencies in software development, in technology, just like, mechatronics, that it's your specialty, or data analytics. So this change in the workforce directly impacts the qualification of the employees. And with the speed of the innovation, there's a gap in the human knowledge in which companies somehow they have to fulfill. So until our education system, they can actually catch up with all the qualification needed, do you see the companies taking this role to qualify the workforce? Or maybe is this an opportunity for specialized schools to offer courses and modules according to the industry's demands? So what's your thought on that?
Yeah, I think definitely we are facing a change. So the new, I would say, engineers or people involved in this digital era has to acquire new skills that we are not having now in our education systems. But I see, listen, when I help companies to the digital transformation, I find very often what I call the Analysts Dilemma. So the dilemma is that, okay, should I teach this algorithm, machine learning algorithm, how I do my job, and then this algorithm will do my job for me or for the company, so I'm feeding the monster that afterwards will eat me. And I think this is not the right approach of facing these situations. It's like we say, because due to the use of the email, now many post office employees are without employment. That's not really the case, or because of the train, so we lost the production, the local production. That's not the right approach. So, in my opinion, we have to somehow change to new skills. So we have to learn and maybe change the education system. But specifically, I see these two tendencies, that everybody is encouraging young people to study IT or software or programming, which is that's fine, absolutely. But we still need mechanical engineers, for instance. We still need people who understand the systems, the electronics, the mechanical components, because they are the ones who will think what to measure and what are the drivers to predict or to communicate machine to machine. So this is the first thing, that it's not only about IT. Okay, yes, the IT are not these guys who repair our email or were installing printers. Of course, they are not. Now they are in a much better position because they will help us to integrate these new technologies. But on the other hand, we still need like architects, we still need mechanical, electrical engineers, whatever, or food processing engineers. So that's definitely, there have to be someone who really understands the systems, let's say. So on the other hand, a very common mistake is that when a company wants to go and try to implement these new technologies, that they do it without any strategy. And this, I don't know why, but this is very common, that they hire a very young IT guy, and they say, okay, do whatever you have to do to apply machine learning, for instance. And this guy doesn't understand the process. Nobody explains him what to do, what they want to do, what is the main objective of this project. It's just something, and after 3 or 4 months, there is no results, and they say, "Oh, come on, this is," and they think the technology is still not available, or is not mature enough, or many other things. But they don't see this in an holistic perspective. So I think the education system will change, but not that dramatically as many people are expecting. For instance, now I see young students. They say, "Hey, do you really mean that all careers will last, I don't know, depends on the system, 3, 4, or 5 years? Really? All 5 years? Regardless of the field that we are studying? Is it really 5 years for all? Or you are following some kind of rule that is without any technical reason or any scientific-based decision that it has to be all 5 years?" So I like this kind of arguments, but somehow engineers have to go to the university, learn the basis, because on the basis is everything you need to know to face the ever problems or the ever issues that any company will face, especially if it's asset intensive companies.
Yeah, that makes a lot of sense to me. So everybody, we're coming to the end of the first episode. We covered the basics of the Industry 4.0. As usual, as most of our discussions here in Future Hacker, we always have to somehow involve the main issue we currently have, which is, catching up with our educational system, right? So on the next episode, just stay tuned as we're getting deeper into a couple of new technologies that the industry is currently using. So stay tuned, everybody.
Future Hacker, Life, Path, Future.